Okay. Okay, let's try this again. So, number 1 on 474, we'll use like our percentages, just like we did the other day. So the weight of sodium chloride, and I think it does tell you, but look, it says each 100 milliliters contains that. So this is asking for the weight in the whole bag of fluid. Okay, so if we set up our percentage, our ratio percentage like we just did, we know, so our sodium chloride is what percentage? 0.9. 0.9, right? So 0.9% over, what does it always go over? 100, right? Percentages are always over 100. And that equals, so we want to know the total number. We're trying to figure out this. So then the total,
500 milliliters.
500 milliliters is how much.
Oh, yeah.
There we go.
It's going to be 450, I think.
Well, you just work this out like your normal
Algebra
stuff. So 5 times that, so yeah, it's actually 4.5, right? So 4.5 grams in that whole bag. That make sense?
Right.
Okay. So then dextrose, we work that out, fill that back in with the same thing. Except now we've got a different percentage. So what percentage dextrose do we have?
10.
10 over 100 is X over 500 milliliters.
5,000 divided by 150.
5 times 10 is 50. Okay. So that means we got 50 grams in the whole bag. Okay? That makes sense? Am I good with that? Really easy. Okay, look at number 3. 50 milliliter IV piggyback contains, and that one is piggyback. Somebody put IVP the other day for piggyback on the abbreviation. IVP is push, IVPB is IV piggyback. Contains penicillin 1.5 million units. The patient has received 35 milliliters of the medication. How many units have they received? So this is still going to be the same idea. You're still going to set this up in a ratio format. So they received 35 milliliters
Of 50.
of the 50. We want to know how many units they've received. So look, 50 milliliters is 1.5 million units. So it's just X over 1.5 million.
So it's going to be like 1,500,000.
Okay. So just multiply that. Zeros, right? What do we get?
Yeah, 1 0. Get a calculator? Yes, I'm still grounded from my phone.
Are you still grounded?
I'm still grounded. I have a 74 now. Hopefully my extra credit should bring me up. And then it's 2 bonus points.
1,050,000. That's what I got.
Hold on, 1,050,000. Okay, 50,000, not 500,000. Okay.
Yeah, 1,050,000.
That sounds about right.
Okay. Does that make sense? How you set that up, ratio? Now that I've got my brain on straight. Okay, let's keep going.
Number 7.
Let's do number 6. No, we just did units. Let's do number 7.
Yeah.
Says 476 says 1 liter of D5 normal saline contains the potassium chloride as shown on the following label using the entire vial. The vein infiltrates after 900 milliliters. You know what infiltrates means? That means that the IV tubing has come out of the vein, but it's still inside their body. You know how the catheter, like it should sit inside of the vein. Well, if it comes out, like it gets moved around and it comes out of the vein and then it just gets in their body, well then all that fluid is not going to go into their vein, it goes into all that surrounding tissue. Really irritates it, it usually will turn red and get really swollen. And that's why it's really important, nursing-wise, to always check, you know, the status of their IV Every time that's part of their assessment is you check their IV. And you can usually tell, like if somebody has an IV in their hand and all of a sudden it starts infiltrating their hand, it'll pop up like a marshmallow. All that fluid is in the surrounding tissue. Okay, if it's got something caustic in it, like if something in that IV fluid is harmful, it's going to burn and be really red and not good.
So is that why they always do like in the top of the hand or like the flat part of the arm?
I think they do those areas just because those veins are really superficial, so they're easy to get to. The bend of the arm is usually not a great place for an IV because it can easily get moved out as people are moving.
So
that's why the forearm and the hands are good areas because they don't get so much movement, Okay, so it says how many milliequivalents of I was like, where's the label? Here it is. Potassium chloride were added to the fluid. So, okay, so here's what we have. We have D5 normal saline contains potassium chloride as shown on the label. So they used all of it. So we've got D5 is our fluid, and what's been added is, look at the potassium chloride. So how many milliequivalents have been added total? How many's in that whole vial? What does it say? The label's at the top of 476. Okay. Is it the 40?
It says 2 milliequivalents
yes.
for every milliliter.
Right, but it says that there's 40 milliequivalents in the whole vial, and they said they put the whole vial into the bag of fluid. So yes, so the answer to that is 40 milliequivalents. Okay. Now it says how many milliliters were added to the fluid.
20.
20, because it tells you that there's 20 milliliters in the vial. Or if you worked it out, that's what you would have gotten to. Okay, how many grams of dextrose did the patient receive before the infiltration? Okay, so grams of dextrose. So how do we know, what do we know about the dextrose? What percentage of the fluid is dextrose?
5.
5, D5, okay? So then we put this in as 5 over 100, because that's our percent. Remember, percents are always over 100. Now it wants to know how many grams did they get before the infiltration. So how much did they get? How many milliliters did they actually get? How many milliliters of fluid did they get
20.
before it infiltrated?
20. 90. 900.
900. See, it says the vein infiltrates after 900 milliliters have been infused. Read the question.
So
okay. So that's what we're wanting to know. How many grams of dextrose did they get before it infused? So they already got 900 milliliters of the whole fluid. So we want to know specifically dextrose.
There's only 20 milliliters in the bottle.
We're not asking about potassium right now. It's asking about dextrose.
Oh, okay. Okay. Just kidding.
So that's one thing that with these, you've got to read your question really good and go back and reread it. Okay, so 9 times 5, so that's 45 grams. That's how much they got. Makes sense? Okay. All right, next question says, how many grams of sodium chloride did the patient receive before the infiltration? Okay, so what is our percentage of sodium chloride on here? What fluid are they getting?
Potassium.
What fluid? What's their base IV fluid?
Dextrose. Normal saline.
D5 normal saline. So what percentage is our normal saline? What percent? 0.9%. Normal saline is always 0.9%. Okay. So if you forget and you can't figure it out, it's on 472. Tells you that little IV section down there. Okay, so if I'm going to figure out how much they got here, I'm just going to fill it in the same way as I did before. 0.9 over 100, because that's a percentage. Percentage always go over 100. And then they got 900 milliliters. Okay. 100, 100, same idea. 4 point. Oh yeah, we did 45 grams. This one's 4.9. I was like, I'm going to keep those together. They're not. So 4.9 grams. Everybody good with that? Mm-hmm. Wait, I didn't do that right. 9 times 9 is not 49. 9 times 9 is 81, isn't it? Mm-hmm. 8.1 grams. There we go. Thank you. Oh, okay. I was doing 7 times 7 in my head. I don't know why. Okay. So you're just going to have to, if it's asking these specific type of questions, ratio is definitely the best way to go. When you're going to figure out dosages and stuff, we'll just look at someone else. Okay, let's look at the last question. It says, how many milliequivalents of KCl did the patient receive before the infusion was discontinued? Okay, so think this through. How would you, don't tell me how to work this out.
All right, so if you have 100 milliliters, after he got 900 milliliters, and then he lost 100 milliliters.
Yeah, but we're not worried how much lost. But yes, I hear you.
But how many milliliters KCl did the patient receive before infusion? So 2 milliequivalents for every milliliter in the vial, right?
Mm-hmm.
How about what?
Okay, think about it. Just like we worked the other ones out, we'll go over doing percentages, like we did 5% dextrose and 100 milliliters. Okay, so what do we know about potassium in this fluid? How much do we have?
Not very much. 40 milliequivalents for
In how much?
40 milliliters.
No, because we added the potassium to the fluid.
Okay. In a liter.
In a liter. There you go.
Here we go.
So we've got 40 milliequivalents of potassium
in 1 liter.
In 1 liter.
Only got
1,000 milliliters because we've got
900 of them.
And they only got 900.
Bye, yeah. There we go. We're getting somewhere.
There you go. See, everybody see why? Because there's 40 milliequivalents because they added this whole vial to that 1 liter of fluid. So in every liter of fluid, we've got 40 milliequivalents of potassium. But they only got 900, so we want to know how much they actually got, how many milliequivalents they got. Okay? I'm not going to trust my math today.
What are you talking about?
36 milliequivalents, what they got.
Yeah.
Right? Right, 9 times 4 is 36. Divided by 2. Oh, okay. 9 times 40 is 360. Okay, by 10. Sorry. Just get rid of that 0 right there.
Yeah.
Okay, everybody good? And why don't you guys work out one? Why don't you guys work out number 9?
Gosh.
Let's make sure you guys can do this on your own.
We work it out a little bit. I think he wants to get a piece of paper. Oh, are we? Oh, yeah. Right, I need one. All right, the second one is throwing me off here.
Just like the last one that we did. Look at the dextrose percentage. first one, like last week's problem. What we just did.
I'm gonna say it's this.
Okay, so the first thing, let's see, it says physician orders fentanyl citrate 50 micrograms to be added to D5W 500 milliliters. The medication is available as 10 micrograms per milliliter. So first, we just want to know how much medicine do we add to the fluids. We want to know milliliters. Okay, so we know what is our what's available.
10, yeah.
Or milliliters. On every milliliter, we have 10 micrograms.
And he wants 50 of them.
And they need 50.
So you're gonna have 5 milliliters.
Right. So 5 milliliters is how much we're adding. Okay. So that's the answer to the first one. If the patient receives 400 milliliters of the fluids, how many grams of dextrose have they received? So this is just like what we just did.
I'm gonna say 20.
Okay, so what do we know is our percentage of dextrose?
5.
5. So 5 over 100. That's our percent. And how much total?
400.
400 is how much they've gotten. Yeah, so 20. Okay?
Okay, but I have a question.
Yes.
You're working with milliliters there. Your 100 and 400 are milliliters.
Right.
That's your milligrams or 100 grams.
Would it matter? Because
No.
at first it was.
This is 20 grams. Yeah, it doesn't matter because this is, remember, percentages and concentration are always in grams per 100 milliliters when you're looking at it. So that just gives you a strength. Now, the medication that we're adding to this is in micrograms. Okay? That this is just talking about a percent, like our percent dextrose is always in grams per 100 milliliters.
Okay.
So now how many milligrams of fentanyl has the patient received? This is like that last problem we did. Okay, so we know 50 micrograms is what was in the total amount, that 500 milliliters, right?
Mm-hmm.
So how do I set this up then?
You have 50 over 500.
50 micrograms over 500.
And equals X over 400.
Good. Equals X over 400. And we
Right.
have
40, I believe.
yeah, 40. Okay, so 40 micrograms is how much they received.
I don't you have to move the decimal because it's asking for milligrams?
No, this is just, oh, milligrams. Yes, you're right. You do. That's 40
So it'd be
micrograms.
0.4.
Okay, so milligrams would be in 1, 2, 3,
Is it
0.04.
I was just 2 of it.
Yeah, it's 3. I bet that's a typo. I bet they were supposed to have set micrograms. There's a few typos. Okay. All right, let's keep going. Let's go to the next section. There's another picture of IV tubing on there. You guys can see that. Look at 482. So this time we're going to look at how to figure out our flow rate. So how fast the medicine needs to go in, how many drops per minute we need to count out and all that. All right, it says the tech alert at 482 says the number of drops per milliliter for the infusion set is found on the box. Tubing is not interchangeable. So it's really important that you look at that drop factor whenever you're looking at your tubing. Like I said, on here, it's on the package. So that's really important to look at. Okay, so here's a formula for calculating the flow rate. I'm probably going to use dimensional analysis, but we'll write down this flow rate anyways. I'll write it down in case you guys want that. So the amount of fluid, it says, times the admin set, whatever it says the calibration is. So that's just your how many drops per milliliter, and then over the time. Now, I'm going to use dimensional analysis because you can use it on everything. So let's actually go. Oh, I do want you to look at these. There's a macro drift and a micro drift tubing on here, and see where it tells you. This one on the left has 10 drops per milliliter. You know, it says at the top right-hand corner on page 43. And then the macro one has 60 drops. So that just kind of shows you what it would look like. Okay, let's go ahead and do some practice problems. Okay, number 1 on 486. Says a physician orders 2 liters of lactated, and it shows you how to go through the dimensional analysis steps in here too. Physician orders 2 liters of lactated Ringer solution over 12 hours. The drop factor is 20 drops per milliliter. Okay, so our order is for how much?
20 drops per milliliter?
2 liters of fluid, right? In how long?
12 hours.
In 12 hours.
What number are we on?
1 on 486. And then the drop factor is
20 drops per milliliter.
20 drops per milliliter. Okay, so we're wanting to know how many drops per minute would be infused. So that's what we want our answer to be in. Drops per minute. Okay, so just like we did before, I want to make sure on the left-hand side of my equation over here, we've got drops on top, minutes need to be on the bottom. Okay, that's what I want my answer to be in. So I know I'm going to start with my drops and put those on top. So 20 drops per milliliter. And I want my minutes to be on the bottom. So we'll get to that. We'll just kind of get to that in a minute. I'm going to go ahead and put this into milliliters because it's easier for me to do that. So how many milliliters is it? 2,000 milliliters, right?
Yeah.
So I know I want milliliters to cancel out. So 2,000 milliliters over how long?
12 hours.
Over 12 hours. And then what do we have? How do we get from hours to minutes?
60 to 1.
Yeah. And every hour we have 60 minutes. Okay. So I'm going to cancel out. Let me make sure I've got everything I need for here. So milliliters and milliliters, hours and hours. I'm left with drops over minutes. So that's the same as what I need my answer to be in. That's the easiest way to me to check and make sure I'm doing the right thing. I can put it all in one equation. Okay, so now,
Oh, why do you take the drops in minutes? Zero.
I'm not. I'm just taking the zeros to make it less calculations.
Yeah, but why did you pick those 2?
I don't know. I should have taken one off of here. It wouldn't matter. Sorry if that confused you.
Yeah, it blew my mind.
Well, here, I don't have to do that. It's going to be the same.
Well, I just wondered like why you picked those 2. Like,
I don't know. I just
take off
wasn't. I just didn't even look at the 2,000. So 2,000 times 20 divided by 60 divided by 12, 55.5. But usually with drops, obviously you're going to round it up to the nearest whole drop.
Okay, so I'll just stay with the equation.
Huh?
I stay with the equation. The equation.
So let's do the equation.
Because you blew my mind with that.
This is why I like dimensional analysis though, because I can put everything into one problem. And I don't have to memorize 8,000 formulas. But yeah, let's drop it into the formula and look at that.
You can use the formula on the test, right?
Yeah.
Good deal.
Okay, so flow rate for now. Now you won't be able to on the real pharmacy tech test.
Right.
You won't be able to. Okay, so the flow rate, the amount of fluid, which is what?
2,000 liters.
2,000 milliliters times the administration set, which is
Use the other one. The other one's easier. It's
what other one?
milliliters ordered times drops per milliliter
Oh,
over minutes.
482 milliliters ordered times what?
times drops per milliliter,
Well, that's
and
what we
then
just
minutes
did.
for infusion.
Minutes for infusion over minutes. Okay, so this over how many minutes? You have to work that out over here.
Okay, I see what you're doing now with that dimensional.
Okay. So this should come out to the same thing, although. No,
Take a 0 off the 2000, try that too.
no, it comes out way different. Did I do this wrong? It's not right.
Yeah, that is 720.
This?
Yeah.
What? My head math is not working out for me today. I need to just stick with my calculator.
Yeah, that's right.
Okay, I see what you're doing now with that other thing.
Okay.
You can keep doing dimensional analysis.
I mean, that's why I do it that way though. Okay, let's do another one. Maybe I won't get crazy. Okay, number 3, it says the physician orders 250 milliliters of D5 normal saline to be administered over 16 hours to keep a vein open. The drop factor is 60 drops per milliliter. How many drops per minute would be administered? Okay, so what's the order for? Write down right now.
250 milliliters of D5NS. 16 hours.
Um,
16 hours.
over 16 hours.
The drop factors, this drop.
Okay, so we're wanting to know how many drops per minute would be administered. Drops per minute. Same thing over here. 60 drops
Milliliter,
per milliliter. How many milliliters do I need?
250.
And how long?
16 hours. And then 1 hour for every 60 minutes.
Okay. Oh, whoops. Milliliters, hours. I've got minutes, I've got drops, so I'm good to go on my
So you
equation.
can take a 0 off the 60, 250, and 60.
Yeah.
Would still come out right?
Well, 60 and 60 actually cancel each other out.
Hours too. Because you have to pick 1 0 from each side.
15,
Never mind.
26.
I know what you're saying about the zeros now. When you cancel out those only 2 zeros.
Yeah, I would just pick that.
Because then it can only be, I got you.
Yeah, I got it. Okay, so really it'd be 16. You really can't do drops. You can't do half a drop. So whenever you answer these, you're just gonna have to round it up to the nearest drop. So it'd be 16 drops per minute. Okay, because you can't, like I said, you can't do half.
Would that affect it any if you had like a 1 last drop or 1 too many drops? Like, you know what I mean?
In something like this, no. But now if you've had, medicine that you're only giving a little bitty bit of, like a newborn baby, and you only give them 10 milliliters over, an hour or something like that, then yes, that could potentially affect them. But does that make sense?
Yeah.
Okay, so now how many grams of dextrose are in these fluids? How many grams of dextrose?
Well, if you have 5% over 100, you have 250. Whatever that will come up.
Okay. 125 over 10. 12.5.
Mm-hmm.
Okay, so 12.5 grams. Okay. Now sodium chloride. Same equation, except what am I going to change out? Julia, put the office, please.
The 0.5 would be 0.9.
Yes. I don't want to do that one. Calculator, sure.
It's been 225, 2.25.
Wait.
That was 22.5.
22, well, let's do 250 times 0.9 divided by 100, 2.25.
Okay. What was the other?
Other one, what?
What was the other answer for dextrose?
12.1.
Okay.
Now it says how many milliliters will be administered per hour. Okay, so this one's a little different. So what do I want my answer to be in?
Milliliters.
Milliliters per hour. So set this up. And every milliliter we have what?
60 drops.
60 drops. Actually, we don't even need that. We want milliliters per hour.
Well, how many drops did we
We've
have last
got
time?
250 milliliters per 16 hours.
No question.
So that's all we have to do. 250 over 16 divided by 16. Yes.
Okay. Well, how many drops did we have last time? Like, how many drops did we have per minute?
Drops do we have for what?
Per minute. When we did the drops per minute, how many drops did we have per minute?
2.
Okay, it's like
Oh, yeah.
16 times 60. That's too much. Never mind. Just kidding.
Yeah.
Just kidding. You did it right.
Yes, you could do that, or you can just divide 250 by 16.
Yeah, that's funny.
Okay, good deal. What, everybody good with that?
Yes.
Okay. All right, let's do this last little section on types, page 491. Because in some instances, the physician will provide an order for the amount of fluids to be infused and the milliliters per hour without the specific time. So like the length of time, like up here we've got it's over 16 hours. They may just say, okay, give them 50 milliliters per hour. And then you figure out the length of time. That's what they're saying. Okay, so let's work out a couple of these. Go on to number 1 on 493.
It says 15 drops a minute. The drop factor is 10 drops per milliliter. They're about to get a lot of medication.
Okay, so there's a formula for this too. Did you see that?
No.
It's on,
Oh, is it the other formula?
oh yeah, it is. It just says flow rate.
Amount of fluid, calibration.
So, number 1, it says a physician orders 500 milliliters of D5 normal saline to be infused at 15 drops per minute. The drop factor is 10 drops per milliliter. What time would be necessary to infuse these fluids? So look, our answer's in what? First answer is in
Minutes.
minutes. So I want to make sure I end up with minutes on top in my equation. So our order is for what?
500 milliliters of D5NS.
500 milliliters. And what else do we know?
The drop factor is 10 drops a milliliter, and it's 15 drops a minute.
15 drops per minute. That's the order, right? Or the
That's
order.
a lot.
500 milliliters at 15 drops per minute.
Yes.
So I want my minutes to be on top. So what am I going to put here?
You're going to put a minute over 15.
So 1 minute, we get 15 drops.
And then on your next one to the left, you're going to put 10 drops over a milliliter. And then next one, put 500 over.
500 milliliters is our order. All right, we ended up with minutes, so that checks off our equation and makes sure we've got the right stuff going on. And what do we get?
500 times 10 is 5,000. By 15 is all.
333. That's not right. Okay.
333 minutes. That's a long time.
Okay.
5 by 60.
So how many hours then? Yeah. Divided by 60, right, to get hours.
Yeah.
Or if you wanted to add that on here, you could do
Maybe 5 hours at least.
60 minutes and divide it again. Yeah, 5.56 hours.
So 5.5 hours basically. So they're getting like a milliliter and a half an hour. Seems like a lot.
Yeah. A lot. You need a milliliter and a half per minute.
Yeah. This seems like a lot trying to show through a lead.
a milliliter per minute. I mean, a milliliter is only some of my regular syringe over here. Milliliters, not very much. I mean, an IV push, you can push medicines, you can push 10, 15, 20 milliliters if you need to at one time.
That's crazy. I'm gonna never have to do that.
All right, let's look at
It's like
number 3.
but except gut ball through autos.
Okay, number 3. Physician orders amikin, it's probably amikacin, I'm guessing it's a generic. 1 gram in 100 milliliters, D5 water to infuse at 25 drops per minute using an infusion set calibrated to 60 drops per milliliter. So what's our order for?
1 gram and 100 milliliters of D5W.
1 gram, 100 milliliters, is that what you said?
Yes.
Okay, what's our drop factor?
60 per milliliter. That's gonna be 25 a minute.
So we're doing this medicine at what speed?
25.
25 what?
Minute.
Drops per minute.
Okay. So what's the running time for infusion in minutes?
What do I have? What?
Why don't you guys work this one out?
It's 600 divided by 25.
600?
Yeah. Is that right? A minute? That's 24 minutes.
Work it out.
But that's not seem
So we
right.
want
I got
minutes.
2.1.
Work this out.
That dude is
Okay,
flowing
so
at
in
24
every
minutes.
minute, what do we have?
25 drops.
25 drops. And what do we know?
You have
60 drops
milliliter.
per milliliter, right?
I have 100 milliliters.
Okay.
100 times 60 is 6,000, not 600, Jacob. So you get. I was about to say, that seems a little flow when you get 24 minutes for 100 milliliters.
6,000 divided by 25 is what?
240.
240 minutes.
How
Okay,
much?
so
In
how
about
many
4
hours
hours.
is that?
40.
4 hours, good. Now it says if the drug is recommended infusion time of at least 1 hour, is this order safe for the patient?
Yeah.
Yeah, they're getting it over 4 hours, so sure. Now, how many milligrams of amikin would the patient receive in 10 minutes?
Look, I'm just kidding.
Okay, so we can work this out a couple ways. We can just do ratio. Okay,
Wait,
but let's
what?
think this through.
In milligrams of everything. Okay.
Okay, so we can just set this up. Ratio and proportion is probably the easiest way here to do this. So we know they're getting how much in 240 minutes. How much
100
amikin
milliliters.
or amikin?
100 milliliters.
Well, we're wanting to
1
know
gram.
though how many milligrams.
1,000 milligrams.
Right, so they're getting 1,000 milligrams in 240 minutes. Does everybody see why?
Yes.
We've got 1 gram in that. So in 240 minutes, I'm gonna put my minutes on bottom to make this easier. So in 1,000 milligrams,
You get
they're getting that in 240 minutes.
So I
We
mean,
want to know how much they're getting in 10 minutes. So what do I put over here?
10, x over 10,
X over 10.
and you
Okay.
cancel out the zeros. Oh yeah.
So 1,000 divided by 24.
Good day. Okay.
41.67.
41.67
Milligrams.
milligrams in 10 minutes. Okay? Good. Everybody good?
Yes.
Feeling okay with that?
Yes.
It's going to take a little brain power to think some of this stuff through.
I don't want to recover.
I know.
Oh, thank you.
Okay, I'll leave it at that. Same thing, just do the odd ones on here. Okay. There's 20 questions on this one, so. No. Yeah, there's 20 questions. If you look at the back, on page 513 at the back of this chapter, there's like a little cheat sheet kind of the flow rates and all that formulas and stuff if you need some of that. Okay, so just think it through, what makes sense, how
Use those
figure this out. This is pretty typical pharmacy, or at least hospital pharmacy. This is very typical nursing that, because sometimes this is just